Okay, the good news is I have everybody seated, I think, so I'm going to ask you to please rise for the invocation to be given by Chaplain Jim White, Chaplain Corps, U.S. Navy, Office of Chief of Navy Chaplains.
Let us pray. Holy God, in this historic century-and-a-quarter milestone year for the American Society of Naval Engineers, we give thanks for its rich heritage, its tremendous contribution to the naval engineering community, and for its support and promotion of the career field of naval engineering. Today we celebrate with those who are recognized in the name of those who have gone before them, leaders such as Rear Admiral Thorwood Solberg, who passionately pursued research leading to solutions of shipboard problems. Rear Admiral Frank Jones, whose commitment to major maintenance and alterations was pioneering. These awards and those named for Jimmy Hamilton and Admiral Claude Jones signify the continued commitment of engineering professionals to excel for their shipmates, their Navy, and their nation. Bless them with continued success and excellence. And as we gather in the grandness of this place for this significant event, for which we ask your blessing, let us never forget our sailors, Marines, soldiers, airmen, and Coast Guardsmen who are in less grand places today, who are forward in harm's way. Watch over them and be with their families, protect them, and bring them home. These things we pray in your holy name. Amen.
Nothing like God to bring a little quiet and order to the audience. Please be seated. Thank you, Chaplain White. God bless you, too. I'm going to hold off on the introductions until after we've eaten. Lunch service will begin as I'm making these couple of remarks, so just enjoy a wonderful lunch sponsored by ABS. I'd like to welcome you to the annual awards luncheon, and I'm delighted that so many of you are here to celebrate at the beginning of our 125th anniversary of our society. We've got a relatively long program, and we're already well into the afternoon, so I'm going to dispense with introduction and acknowledgement of many of the guests today. But we couldn't exist without a tremendous amount of leadership and support from a great number of people who volunteer their time freely to organize and participate in events like this and to provide direction and energy for many of the Society's other programs. I'm going to ask one individual out here to rise and be the surrogate that we can recognize to thank all those volunteers. Person I'd like to ask to stand is Mr. Gerald M. Ward. I don't know where Gerald is seated. Gerald is celebrating his 50th year as a member of ASNE, so let's give him a round of applause. Thank you, sir, for your long and faithful service. I'm going to get right into the awards. The first one is going to be the Jimmy Hamilton Award. It's presented for the best paper to appear in our Naval Engineers Journal during the award year. Papers are recognized based on the professionalism of the subject matter, the depth of treatment, and the lasting value, clarity in composition and style, and individual effort. So please join me in welcoming Rear Admiral David C. Johnson, U.S. Navy, who will present the award.
That's a good first step. Thank you. Thank you very much. Well, thanks for inviting me up here to do a few brief remarks for my team that put this paper together and actually developed an approach that I think is increasingly apropos in the environment we're in, which is focusing on the life cycle and how we sustain our ships. We first, when I was back as a Virginia program manager, took and tried to apply an analytical basis to give us some firm foundation in how we could assess fairly whether what we wanted to do, which was fairly different, to go and change a ship's design and accelerate its velocity through the shipyard and lower its cost. if you follow classical theory, that's not really how you do it. And in fact, we used PA consulting with a few of our team members to give us not only confidence that we were doing it right, but actually pointed a few things that we needed to pay special attention to, like get the design done, get it done right, and get the material there on time. And so we focused on the right things, but it was all from a position of data and a foundational analysis on good analytics. So if you zoom forward, now we're working on doing a better job of integrating Virginia into the op cycle and the fleet's use of that asset. And again, we lean back on a team led by now Mike Jabalay, who was the program manager at the time, with his crack professionals like Charlie McNamara, our R&D manager, and Christy Goff, our fleet support director, to go and pull together the same resource that we developed in our investment in the acquisition side to go apply this problem and then work very closely with the fleet. So that's where Joe Bradley comes in, a 26-year Navy vet. I first met him way back when I was doing the Pennsylvania post-shakedown availability in probably 1990, ways back. But Joe had a wealth of experience. He worked on the N-43 staff for the Sublant commander, and between that team, we took and built a model that looked at how we deal with maintenance on a systemic basis, not just what you put in an extended docking SRA or a CMAV, but actually how that impacts the downstream maintenance and the management of your IDTC. How do you deploy the ships, how do you prep the ships, and how do you work all that in? It is a system. So this paper, Maximizing Platform Value and Increasing Virginia-class Deployments, was taking an analytical, system-based approach to make sure that A, we could maintain the ship in the budget that we thought, but B, we actually got 15 deployments out of this asset, which is really what we should get for our return on investment. So it is, in my view, an outstanding example of using modern modeling and simulation to assess and then solve real maintenance and modernization life cycle issues with the end result, the right application of investments to gain the most benefit in the ship's performance. So a very well done effort by the team, and I applaud them greatly, and I'm so proud to be the one to introduce them. So if they will join me up here, we'll present this award.
The American Society of Naval Engineers takes great pleasure in presenting the Jimmy Hamilton Award for 2011 to Christy Goff, Charles McNamara, Joseph Bradley, Christopher Trost, William Dalton, and Rear Admiral Select Michael Jabaley, Jr., United States Navy, for the best original paper published in the Naval Engineers Journal during the year 2011, as set forth in the following citation. The paper, Maximizing Platform Value, Increasing Virginia-class Deployments, was published in the Naval Engineers Journal, 2011, Volume 123, Number 3. The authors describe actions arising from pressure to reduce total ownership cost, TOC, that may have the potential to inadvertently limit available platform mission time if the full consequences, including indirect impacts, are not rigorously assessed and analyzed in advance. The authors present a comprehensive simulation analysis for likely results of alternative plans and/or policies to reduce TOC and provide insight into where changes can be made across multiple stakeholders to efficiently and effectively achieve program goals for deployments. The simulation is integrated into the Virginia-class processes to identify specific areas where changes have high leverage to increase mission time, evaluate specific changes proposed by the TOC effort, and track progress toward achieving mission time goals. The authors describe their method to capture TOC effectiveness through a time-phased, dynamic simulation of the lifecycle employment of Virginia-class submarines, including depot maintenance time, that was developed to determine the likely submarine employment consequences of the plans, policies, and constraints of the stakeholders involved, ensuring that the lifecycle maintenance plan targets were achieved. The simulation is validated against historical performance of Los Angeles-class maintenance execution at public shipyards, explicitly adjusting for known differences in Virginia-class work packages. The authors explain the fundamental aspects involved in both clearly written and well-presented graphical forms that made this paper stand out from other papers. The authors have demonstrated superior knowledge of the subject matter and explained it so that a wide audience can benefit from the results of this study. The The authors are highly deserving of the Society's 2011 Jimmy Hamilton Award.
Thank you very much, and thank you, Admiral Johnson. It was an honor to have our symposium paper selected for publication in the Naval Engineers Journal, and an unexpected greater honor to be selected to join the ranks of previous Jimmy Hamilton Award winners. We also appreciate the opportunity to let the greater naval engineering community know about the culture of continuous improvement in the Virginia-class program. We're pleased to say that the Ohio Replacement Program team has already adopted the RTOC process to drive out life cycle cost right from the beginning of the design process. As Admiral Johnson mentioned, the Virginia program has a history of tackling large objectives and succeeding at them. The 2 for 4 and 12, which I'm sure everyone is familiar with, that began under Admiral Johnson's tenure, set a very high bar for us to follow. And when Charlie and Christy and I were trying to figure out how to best approach reducing total ownership cost, we came up with an idea of how to discuss it and how to sell it that kind of played on 2 for 4 and 12 with the 315 approach, reducing major depot level availabilities from 4 to 3 and increasing deployments over the life of the ship from 14 to 15. So that focus then basically meant that my part of the job was done. Having set the vision and the goals, and then I dumped it in the lap of this team over here. And they really excelled with an innovative technique of modeling and simulation to really start to drill down to what made the maintenance availabilities the length that they were, that made them cost the amount that they did, and that kept the ship in the shipyard instead of being where she needed to be out on deployment. So we have reached milestones since that paper was submitted. The RTOC initiatives to support the project goal of 315 have been included in the Virginia Submarine Block 4 technical baseline, which sets the requirements for the Block 4 contract, which is currently, we've released the request for proposal, received the proposal from the shipbuilders, and are currently in the review and negotiations process with the goal of awarding that contract later this year. So these technical requirements that implement the 315 process have already been enshrined in the requirements for the contract. Nothing ever happens very quickly in shipbuilding. The 2 for 4 and 12 started in 2005, so 7 years ago, 7.5 now, and we authorized the first ships that were originally planned to meet that goal only last year. We got to 2 in FY11, 1 year early, which is great. But even though those ships are only 2 and 1 year along in the actual construction, there's a little advanced construction, advanced procurement that leads up to that. They are already meeting their goals and are on track to achieve that mark of 2 submarines, $4 billion, as measured in fiscal year 05 dollars. And we similarly are on track to meet the 315 goals, having enshrined those requirements in the contract, having had the shipbuilders along with us the entire way, and they are ready to go off and execute that as soon as we award the contract. So that's a great news story. So the authors of the paper, Charlie, Christy, Bill, Chris, Joe, outstanding work on the project, but the RTOC project would not be also successful without the superb efforts of the entire NAVC, engineering and submarine maintenance and sustainment communities, our design and shipbuilding partners, General Dynamics Electric Boat and Huntington Ingalls Industries, Newport News Shipbuilding, and our ultimate customer, the warfighter. So on behalf of the entire team, we thank the ASNE membership for this award. Thank you.
Thank you very much, Captain, and congratulations to the entire team. And thank you, Admiral Johnson, for making the presentation. You know, the work that they did here is obviously very important to the nation, to the Navy, the fleet. But the fact that they wrote a paper about it is what's very important to the naval engineering community, because that's the way the rest of the naval engineers in our community can really understand more about what's happening in one area. So it was a tough competition. We had a lot of good papers, and it's a superb paper that was selected to win. The Solberg Award. It's given to an individual who has made a significant contribution to naval engineering through personal research during the past 3 years. So please join me in welcoming Dr. Norbert Dorey, who will present that award.
Good afternoon. It's a pleasure to be here, and I'm very honored to present the Solberg Award to Dr. David Singer of the University of Michigan. As we stated, the award is named for Rear Admiral Solberg, who was president of ASNE in 1949, concurrent with his tenure as the third chief of naval research. Admiral Solberg's greatest forte was the pursuit of basic and applied research leading to solutions of shipboard problems. And basically what I want to say here is that Dr. Singer's work exemplifies this transition of basic research into being able to solve our Navy's problems. Roughly about 5 years ago, we were setting up the design teams to design the ship-to-shore connector. This is an air-cushioned vehicle, so follow on to the LCAC. We had not designed an air-cushioned vehicle since the LCAC over 30 years ago. And so the ability of the United States to go do this, it was not clear that we had the expertise. In fact, we decided to do what expertise existed was largely within the Navy itself with some support contractors. So we decided to have this design team be Navy-led. This would be the first preliminary design of a Navy-led preliminary design since the LPD-17 over 15 years. We also had a compressed schedule, surprise. And so when we started laying it out in our traditional ways of doing a point-based design and the normal design spiral, which we all learned as a naval architect, Howard Fireman, who was the chief naval architect at the time, and I quickly came to the conclusion it wasn't going to work. I mean, we couldn't get to a converged design. We weren't, the chances of completing it on schedule was virtually zero. And so I said, okay, we have to find an alternative. And luckily Howard knew Dr. Singer, knew of Dr. Singer's work, and we brought him in, and we tried to learn real quickly whether what he had in set-based design could actually help us. And we said, hey, there's something in here. We knew using the traditional path wasn't going to work. You got to go to something new. We knew it was a little bit of a risk, but at that time, it looked like to be the least risky of all our risky solutions. And so we brought Dr. Singer in. We brought a lot of young engineers in as well, a lot from NAVSES, a lot from Carter Rock, a lot from the organizations that had the expertise. And we went through a very, the first good application of set-based design on a Navy preliminary design problem. And in all, the results as they're coming out, we managed to finish the design on time. It was largely within budget, and one of the hallmarks of it is that the unit cost of your design from the early estimates, the cost actually went down a little bit. I don't think, they head steady or a little bit down. We fought cost growth. We kept it affordable. We completed on time, completed on schedule, and a lot of that is due specifically to what Dr. Singer did for us and helped us out in those design teams. And more importantly now, we also now have a trained workforce who understands how to do this kind of a design process. So when we go through and design our next ships, we have that core amount of capability. And so basically what I want to say is, Dr. Singer is one of those few researchers who can actually do real work, create something, create new knowledge, and then apply it on a real product and see it within his own lifetime. And that's and that's extremely exciting, and it's really, I'm really happy to be able to recognize him for his accomplishments. So Dr. Singer, please go.
The American Society of Naval Engineers takes great pleasure in presenting the Solberg Award for the year 2012 to Dr. David J. Singer for his significant engineering research and developments. Accomplishments in the use of set-based design is set forth in the following citation. Dr. David Singer served a critical role on the Navy's Ship Connector program during its preliminary design. His efforts in educating the design team in set-based design and managing the design process brought the project to fruition and will continue to influence naval design for years to come. Since its initial successful implementation, Dr. Singer has significantly advanced the use of set-based design methods, improving the ability of highly constrained designs to converge. Most recently, Dr. Singer has applied design space mapping methods and Markov decision process methods to set-based design. The combination of these two approaches has improved the ability to understand the outcomes of design space, the relationships among design variables, and performance metrics. This led to more globally optimized designs that can be produced more quickly and more effectively. Until its use in the preliminary design of the ship-to-shore connector, set-based design was an unproven academic model in naval ship design. Dr. Singer's research efforts in this area validated and led to the first successful deployment of the model. The Navy's current ability to implement set-based design modeling during the design process of naval ships is a result of his work. Set-based design has been institutionalized within the manuals for the Navy's Ship Design Manager and Ship Integration Manager. Moreover, the Navy's early-stage ship design tool environment has embraced the set-based design model and is actively implementing this model in tools developed for use in design of future Navy ships. The recapitalization of our fleet through the implementation of set-based design in the coming decades will be reliant on the innovative work of Dr. Singer. For his path-breaking research in ship design and his contributions to the future of naval engineering, Dr. Singer is truly deserving of the Society's 2012 Solberg Award.
First, I'd like to thank Dr. Dory for the nomination and the ASNE community for giving me this honor. I guess at this point I can finally tell Norbert that it was viewed as low risk. This was unproven in naval design as well as automotive, where it came from, aerospace and others, but I think it's okay now that I'd let you know that. Like mentioned last night by other speakers, no individual award is truly individual. It's from a team. And for my work in set-based design, I'd like to thank two distinctly different groups. First, the Ship-to-Shore Connector. As an academic, you very rarely, if ever, get an opportunity to actually apply your theories, as well as, I think, as a young engineer. I'm not 40 yet, so I guess I'm still young. To be actually on a design team was outstanding, and I had the wonderful privilege of working with Walt Mebane and Mike Buckley and Chris Dodd and Craig Carlson on the Ship-to-Shore Connector team, as well as all the engineers on that program. It was truly outstanding, rewarding, and I learned more about not just the theories that I researched, but also how to convey that information. I'm able to take that experience back to the classroom, and I can truly say I do a much better job today than I did then teaching. I also want to thank the person who supports this research, Ms. Kelly Cooper from ONR. You know, Kelly has taken a big risk funding design theories. It's not a popular topic at ONR. It's not as sexy as maybe advanced CFD. But without her support, I would have not had the opportunity to win the ONR YIP Award, as well as the funding to fund my PhD students, which is probably the most important part. Every day I get to go to work and work with some of the smartest, brightest, most talented young engineers that this country has. And at the end of the day, I don't do the work they do. I come up with crazy ideas that they have to implement to get a degree. And I want to thank them, Dr. Alex Gray, Dr. Nathan East, Dr. Justin Gillespie. They're doctors now. Mr. Tom McKenney, who's taking the torch on the set-based design, he has to write a thesis first before we can call him doctor. Jason Strickland, Morgan Parker, Josh Knight, Doug Ritterdink, and all the other countless students have helped in all the experience we've had to do and all the research. So again, thank you to the Society, thank you, Dr. Dory, and most importantly, thank you to all the wonderful students that helped develop this work. Thank you.
Thank you, Dr. Dory, for the presentation, and congratulations again to Dr. Singer for that innovative research in the field of ship production design and systems integration. The next one is the Claude A. Jones Award, which is given to a fleet or field engineer who has made significant contributions to improving operational engineering or material readiness in our maritime forces during the past 3 years. I should add that I was chairman of the awards committee in ASNE when this idea to establish the award was put forward, and I'm sure that the person who really was the impetus on this, Admiral Frank Jones, would be delighted with all of the recipients, including the one that we've selected today. Unfortunately, our scheduled presenter was unable to be here today, but his superiors attested to the quality and importance of the work for which Scott is being recognized. Scott's branch head said that when he saw a message from Carrier Battle Group Commander saying, quote, "My life flashed before my eyes," unquote, due to an unreliable CVN steering control system, he knew it was a job that required the best man, and that meant Scott. The problem was an outdated ship-unique proprietary system with obsolete parts, unreliable mechanical analog components, and reliant on logistic support from multiple vendors. Scott personally led a hands-on, comprehensive analysis and risk assessment and developed a complete wheel-to-rudder system standardization and an improvement plan leading to a new system which is completely government-owned with common and open, scalable, and supportable components and fully integrated logistics support. This will be the Navy's first standard and fully certifiable ship control system. More specifics are included in the citation, so I won't repeat them, but clearly Scott has developed a system improvement that not only provides great improvement in ship safety for nuclear aircraft carriers, but it also significantly improves system supportability and affordability. Scott, would you please come forward to help me present to receive the award? And I'd like to invite Admiral Kevin McCoy to come up and join us to be the surrogate for the gentleman who should have been here making this presentation.
The American Society of Naval Engineers takes great pleasure in presenting the Claude A. Jones Award for Fleet Engineer for the year 2012 to Mr. Scott C. Romalo for a significant contribution to naval engineering as set forth in the following citation. Mr. Romalo's work on the Fleet Standardization Plan is directly aligned to NAVSEA commonality and reduced total ownership cost objectives. His systems engineered, reliable, non-proprietary, supportable, open architecture will dramatically improve system integration, operational availability, and lifecycle support, and will result in a generational shift in how we provide and maintain critical systems over the 50-year life cycle of carriers, and likely across all other vessels in the Navy. Mr. Romalo is the NAVSEA Lead Engineer Agent for CVN Ship Control Systems, Navigation Distribution and Displays, and Integrated Bridge. In this role, he has led the development of system-wide engineering solutions involved in an in-depth, hands-on investigation of the entire configuration. The solutions he provided involve the first wheel-to-rudder systems engineering approach and an integrated class-wide equipment commonality, interface, and software standardization roadmap. At the heart of his plan is a desire to enable the Navy to move away from proprietary systems towards a common, open architecture with government-owned and managed software. Moreover, Mr. Romalo's support and vision for the future fleet maintenance have been likewise outstanding. He has made himself available for routine fleet maintenance projects, and his team has become a proven incubator for developing the highest quality systems engineers and subject matter experts. His team's technical contributions reach beyond their specific mission and will certainly impact the future direction of technologies across the fleet. Having earned the respect and commendations of officers at the highest level, Mr. Romalo's leadership and technical skills will continue to have a lasting impact on fleet system integration and engineering. He is most deserving of the Society's 2012 Claude A. Jones Award for superior performance in fleet engineering.
Before I let Scott talk, let me just chime in here, because I've got some history on the Joneses. If Frank Jones was here, and Frank was an engineering duty officer, and in fact, he was the last shipyard commander at Boston Naval Shipyard, little known fact. If Frank Jones was here, Scott, he would tell you the story about his dad, who as a young officer was on a minesweeper in a squadron off the coast of California during a terrible storm. And several of those minesweepers were lost, and his ship, the USS Memphis, was saved. And he would tell you about the heroic action that his father took to keep the fires burning, keep the boilers going. And Frank personally gave me the book that was written about his father. And what I'm going to do when I go back on Monday, Scott, is I'm going to send you that book. And since Frank is not with us anymore, what I'd like you to do is send it on every year to the next winner.
Well, I first would like to thank President Kiss and Admiral McCoy for presenting this award to me. This is truly an unexpected and a bit overwhelming experience. I'm extremely honored and humbled to be recognized for an award with such meaning and distinguished past winners, such as Admiral McCoy. I obviously would like to thank the American Society of Naval Engineers for the selection, and to my branch manager, Mr. John Dolan, for the nomination, who regretfully couldn't be here today. Also, to many others at NAVSES Philadelphia that encourage and support our team's efforts on a daily basis. I would like to show my gratitude and respect to other award winners this year, Admiral Eccles and Mr. Mike Tangora. Both gentlemen have been involved with some of our biggest challenges and have shown their support to us over the years. The continued support from all our stakeholders allows us to keep these mission-critical systems fully operational. I'm very appreciative for the opportunities we have been given to improve the safety, readiness, and costs associated with the navigation and ship control systems on multiple ship platforms. Being selected is a direct reflection of the hard work and determination that my team members put forth day in and day out to ensure that the fleet's needs are always met. Without their loyalty, dedication, and persistence, accomplishing our goals for standard and sustainable systems would not be possible. Thank you again for this honor.
Thank you, Admiral McCoy, for joining us and for adding that little extra insight into Claude Jones. And congratulations again to you, Mr. Marmallo. Your accomplishments as a lead engineering agent and team leader have set high standards and certainly deserving of that recognition. The next award is the Frank C. Jones Award, and it's presented for major achievements in maintenance and alteration. The award recognizes naval engineering professionals who, over a period of the last 10 years, culminating in the previous year, have substantially and significantly contributed to their agency's intermediate and/or depot-level maintenance and/or alteration programs. Please join me in welcoming Vice Admiral Philip Collum, USN, who will present the award. Admiral Collum.
Well, good afternoon. I'd like to thank the Society for extending both the invitation and the honor to present the Frank C. Jones Award for Major Maintenance and Alteration Achievement to Mr. Guy Holston. Over the past 4 years, I've been lucky enough to work alongside Guy. And I really say it that way, alongside Guy. There are certain individuals in our organizations who are the constancy, and Guy really does represent that. First as his division director for fleet readiness and OpNav N43, then afterwards as the energy and environmental readiness director, and then now as the deputy chief of naval operations for fleet readiness and logistics. I can tell you that none are more professional or more dedicated than him. Throughout 38 years of service to both the Navy and the nation, starting out as a young sailor and eventually as a naval officer and civil servant, Guy has demonstrated unparalleled leadership and excellence in growing personnel and sustaining the operational availability of our nation's surface ships, submarines, and aircraft carriers. He enables the Navy to put warfighting first, operating forward, and being ready as primacy for our mission. His Navy journey started in boot camp back in 1975, and the career combined military-civilian service to the Navy has culminated now in recognizing him across both ship maintenance community as the subject matter expert in fleet operations and ship maintenance. I know a lot of you in this room know him, have probably been on the phone with him. And if you've ever heard him discuss ship maintenance, well, you'll know that Guy is an extremely passionate individual about fleet readiness, a true national treasure, and a readiness warrior. Before we recognize him with this prestigious award, I'd like to note a couple of accomplishments. For the last 2 budget cycles, Guy built and defended ship maintenance requirements that resulted in full funding of ship maintenance. Truly unprecedented accomplishment in recent history. Needless to say, with the challenges that we face today, there is no one I would rather have step into the budget front line to do battle than Guy. His ability to get to the heart of the matter and answer complex questions is truly legendary, not just amongst OPNAV, but I think in NAVSEA and elsewhere around the Navy. Matt Moffett warned me when I took the job in N43. He said, if you get a question about maintenance or operations on ships, go see Guy. But he said, when you do that, make sure you bring a cup of coffee or maybe a thermos and have a couple of hours because you're going to need it. And I can tell you, I got schooled at the right hand of Guy. He prepared my predecessor, Bill Burke, as the N4, for back-to-back testimony sessions, and as all of us who have had to do those, they're no fun. The HASC Readiness Subcommittee of Navy Modeling and Simulation, as well as the Fleet Review Panel on HASC Readiness and Sea Power. So those are pretty tough things to be able to prepare someone for. I routinely call on Guy to prepare me, so Guy is accustomed to regular office visits with me. Leveraging his expertise, he has for years shaped an annual $10 billion budget in maintenance and operations portfolio, and I'd say he's really brought some truly innovative resourcing strategies to ensure the availability of the resources necessary. Admiral McCoy and I today were talking about those issues for the next iteration that we're gonna face. Guy's been essential leadership for that effort. Expanding the analytical rigor in requirements, definition, as well as the introduction of more robust metrics that accurately reflect the impacts of funding shortfalls. When the Fleet Readiness Panel, led by Admiral Belisle, issued its recommendations to improve ship material readiness condition, Guy was instrumental in securing the resources to implement many of the recommendations, most particularly increased regional maintenance center manning, improved ship maintenance planning, and adoption of more robust ship material condition assessments. In sum, Guy has truly been very effective as an advocate for program wholeness in the realm of ship maintenance and operations. And in this maelstrom that we face on readiness debates today, this is and will be critical for keeping our sailors at the pointy end of the spear, sailors and Marines at the pointy end of the spear, truly ready. Over the past 6 months, the Navy developed a plan to provide enhanced carrier presence in support of some challenging global requirements. Well, guess who was at the center of that? Guy. And he was key in developing the plan to maximize that presence and readiness as we look out ahead at the challenges that the United States Navy will continue to face. Guy enjoys the trust of senior Navy leadership for technical expertise and sound judgment, his ability to establish and leverage relationships across all sorts of organizations, most prominently the Fleet and NAVSEA, all of us in OPNAV, as well as to our civilian leadership in the Secretariat, Navy Secretariat and the Secretary of Defense. He has just been absolutely essential to being able to get those points across, and as I said, truly a national treasure. His leadership improves productivity, workload planning, and teamwork. He leverages every opportunity to share that knowledge with the young engineers and the young naval officers that he's surrounded by in N43 and throughout N4 and the rest of the OPNAV staff. Incredibly dedicated, he holds himself personally accountable for fleet readiness and drives that sense of ownership and accountability amongst the staff. He is truly an exceptional leader. It's through his personal efforts that sustained fleet readiness will continue to enable the warfighters to achieve our mission objectives. His expertise is more critical than ever in light of the high winds and heavy seas that we are right now embroiled in. Guy's accomplishments and personal dedication mark him as a professional in every sense of the word, and I truly believe most deserving of the recognition. Guy, if you could join me up here.
The American Society of Naval Engineers takes great pleasure in presenting the Frank C. Jones Award for the year 2012 to Mr. Guy Holston for a significant contribution to naval engineering as set forth in the following citation. Mr. Holston is recognized across various Navy enterprises as the expert on Navy fleet operations and maintenance programs. His ability to leverage that expertise to build high-quality Navy planning, programming, and budget products serves as a model for other resource sponsors to emulate. Mr. Holston enjoys the trust of senior Navy leadership for his technical expertise and sound judgment in all fleet maritime operations and maintenance matters, and has been relied upon to prepare testimony on fleet readiness. Through his unmatched analytical skills and exceptional performance, he built and defended the ship maintenance requirements for 2 successive budget cycles. His detailed analysis of the direct effect of ship maintenance on a ship's expected service life played a major role in securing full funding of the ship maintenance requirement. These efforts greatly enhanced current and future fleet readiness. Moreover, he has significantly improved productivity through solid leadership. He leverages every opportunity to share knowledge and to promote open communication and collaboration to improve organizational effectiveness. He is a polished coach and mentor to his staff. Mr. Holston has set an extraordinary example through his proven expertise, leadership, and character in his role as a fleet maintenance engineer. He is a dedicated professional who is indeed highly deserving of the American Society of Naval Engineers Frank C. Jones Award for 2012.
Thank you very much, Admiral Cullum. Admiral Cullum, ASNE members and guests, thank you for the award. I truly appreciate the honor. However, in full honesty, you have to know that no award is ever won by a single individual. Every single one is the result of teamwork. And the team we're talking about here for what we do is the people in this room and many other people across the fleet. In the 12 years I've served on the OpNav staff, the organization's been blessed with some wonderful leadership. First, at the OpNav N4, the Deputy Chief of Operations for Fleet Readiness and Logistics, officers such as Admiral Phil Cullum and his predecessor, Bill Burke, have ensured that fleet readiness, maintenance, operations, and logistics received a full and fair hearing at the 3-star forums where resources and policy decisions are frequently made. That's where we were today. At OpNav N43, the Fleet Readiness Division, we've been effectively led by a whole bunch of naval engineers. I'm only going to mention a few. Admiral Tony Lingrick, Mark Ugel, Clark Orzali, Joe Campbell, Tom Moore, and currently an aviation engineering duty officer, Tim Matthews. Last at OpNav N431, Ship and Submarine Readiness, I've been really privileged to work directly with talented naval engineers that include Captains Chris Petras, Anthony Malarkey, and then Captain, now Admiral Rick Berkey. It really does sound like a who's who in naval engineering if you think about it. When I arrived at OpNav N431 in May of 2001 to work for then Captain Clark Orzali, and you hear a lot of these names over and over again, I could never figure out if people had to do 2 tours because they did well or because if they were getting a chance to do it right the second time. But, and Captain Orzali came back later as Admiral Orzali to run the division. But I really had no idea I'd still be there 12 years later. I can truthfully say I've never been bored, or, well, maybe almost never been bored. In addition to the routine work that we do of programming ship maintenance, ship operations requirements, supporting budget preparations, preparing readiness testimony, answering Navy leadership, Department of Defense, and congressional questions, and I bet you can figure out exactly what kind of questions we've been answering lately, and mentoring new action officers, which as people alluded to, there's a constant flow of people coming in and out of OpNav. The Fleet Readiness Division has acted as the OpNav action officer for fleet maintenance issues, and we've had a lot of them. Some of the really significant ones across the last 12 years I've been able to be involved in has been the intermediate and depot maintenance integration effort. We mission funded the naval shipyards. We integrated the shore intermediate maintenance activities, the fleet technical support centers, and the repair supervisors of shipbuildings into regional maintenance centers. We worked really hard on surface ship readiness, as was mentioned here. Helped stand up C-21, Surface Maintenance Engineering Planning Program, and get the total ship readiness assessments going. And there are only a few of the issues we got to work on. I've really earned my PowerPoint Ranger badge in this job, because that's really how we communicate inside of OpNav. The ship and submarine readiness branch has never been very large, and it's really gotten smaller over the years. We really, at the moment, to do those things, have a grand total of 10 people that do it. Our influence is much greater than our size because we get incredible support from the entire maintenance community. There have been a lot of times when we have a very limited window to influence a decision, and we've had to reach out to somebody at NAVC, somebody at the fleets, somebody at the TICOM, somebody at the regional maintenance centers, or even in the shipyards and say, I need this piece of information and I need it in the next hour. And you know, almost every time they've come through. Let me close again by thanking you for this honor, and also let me thank you for the support you've given me, our nation, and the Navy. Thank you very much.
Thank you, Admiral Collum, and congratulations, Mr. Holston. Your distinguished 30-year career in the Navy and subsequent work as a management analyst sets an impressive standard for this award. And now, it's my honor to introduce our guest speaker for this afternoon, Admiral John C. Harvey, USN retired. He brings with him an invaluable wealth of technical, operational, and personnel knowledge from his 39-year Navy career. His expertise covers a wide range, including naval nuclear propulsion, surface ship and carrier strike group operations, Navy-wide manpower management, personnel policy development, and a deep and insightful understanding of leadership. Admiral Harvey served as the commander, U.S. Fleet Forces Command, where he was responsible for providing ready, responsive, and relevant naval forces whenever and wherever needed. He was also responsible for providing integrated fleet operational and warfighting requirements to the Chief of Naval Operations to guide Navy-wide resource allocation and serve as a basis for Navy's future force structure development and current force modernization plans. In addition, he served as Chief of Naval Personnel, the senior uniform human resource official in the Navy, and his myriad of accomplishments in these roles include improving the operational readiness of deployed naval forces, increasing performance standards in all aspects of fleet operations and maintenance, strengthening the Navy's operational partnership with the U.S. Marine Corps, and reinvigorating the foundational concepts of accountability, responsibility, and authority at every level of the Navy chain of command. And Admiral Harvey was with us a few years ago at one of our fleet maintenance symposiums, and he set a tremendous challenge before our community. So please join me in welcoming Admiral John Harvey.
Well, one of the things you learn in your retirement voyage, many things you learn, but you learn at a time like this, you win the coveted post-lunch, end of the day, end of the conference speaking role, which leaves everybody just incredibly excited about what is going to be said and how it's going to be said. But many of you have asked very kindly how my retirement is going. And I'd like to tell you that it's been incredibly successful so far. I'm still alive, and I'm still married. So you set the bar low enough, you're sure to get over it in fine fashion. It's a real honor to be back with ASNE today. And as Admiral Cullum said, it's a privilege to be here. I believe in this organization. I've had, as the President mentioned, I've had the opportunity to engage with this organization and with the engineering duty officer community numerous times in the past and have always enjoyed that. We talked in April 2010. I'd been in the command of the fleet for about a year, had learned a lot, experienced a lot, and was able to put that into some pointed challenges for the team, your team, that I'm very, very pleased to say, as you heard from the fleet readiness representatives, many of those challenges have been taken on and have been met. Now, whether they'll survive the next year or so is going to be another challenge for you all. But that's what you do. You meet challenges. And that's certainly what this retired taxpayer expects you to do. ASNE is a great organization with a very rich history that remains extraordinarily relevant to the future of our Navy, particularly the surface Navy. And if I didn't believe that, I simply wouldn't be here. I actually get a choice nowadays as to what I get to do. Now, as grateful as I was for the opportunity to speak today, I must admit I was in somewhat of a quandary trying to properly focus my remarks. As I mentioned, I'm very mindful that this is the last event of the conference in the afternoon, so I know I can't go on too long, no matter how many brilliant insights I have to share with you. I'm also quite aware of the sequestration and the continuing resolution countdowns that are underway, and the many, many adverse impacts that those in this room will soon be confronting up close and personal. Those impacts are certainly weighing heavily upon very many of you here today, whether you're in uniform, whether you're in civilian and government service, or civilian in support out in the private sector. And lastly, it's no longer appropriate for me to speak in such a forum such as this concerning the direct needs of the fleet. That responsibility lies properly with those currently in uniform who are accountable for the operational and material readiness of the fleet. And you have heard from many of those individuals over the past 2 days. So where does that leave me? What role could I possibly usefully fill for you today? Well, my answer came to me as I reviewed the detailed agenda for this year's conference. Studying the student and young professionals program, the ship structure, event track, and the events associated with the Marine Machinery Association spring meeting, it struck me that there was a thread missing from the overall fabric of this conference, and a very important thread at that, one that increasingly caused me great concern, serious concern, during my last tour at Fleet Forces. And that thread is an appreciation, a deep down, truly felt, understood, and recognized appreciation for the human element that is, at the end of the day, the focal point of all the engineering that goes into our ships and systems that you develop and you deliver. What can the sailors really do with what you've given them? That is, after all, the point, isn't it? However elegant the design, however revolutionary the technology, the ultimate judgment regarding the efficacy of that design or the utility of that technology lies with its performance at sea, in the most stressing operational environments our sailors can expect to face. I contend that we have much work to do in this area, particularly when looking at our surface ships alongside our aircraft, our submarines, and indeed the technology we field for our special operations and our Navy expeditionary communities. The complexities that our crews must face are growing rapidly. Are their capacities keeping pace with these complexities? I'd like to read you a quote from Captain S.W. Roscoe's classic history of the Royal Navy in World War II, the War at Sea, 1939 to 1945. He wrote, "Thus the stage was set for Germany to fling into the Atlantic struggle the greatest possible strength. It was plain to both sides that the U-boats and the convoy escorts would shortly be locked in a deadly, ruthless series of fights in which no mercy would be expected and little shown. It would be decided by which side could endure the dangers, by whether the stamina and strength and purpose of the crews and the Allied vessels and aircraft, watching and listening all the time for the hidden enemy, outlasted the willpower of the U-boat crews, lurking in the darkness or the depths, fearing the relentless rap of the Aztec, the unseen eye of the radar, and the crash of the depth charges. Victory depended on whether the men of the merchant navy, themselves almost powerless to defend their precious cargoes of fuel, munitions, and food, could stand the strain of waiting day after day and night after night throughout the long, slow passages for the rending detonation of the torpedoes, which could send their ships to the bottom in a matter of seconds or explode their cargoes in a searing sheet of flame from which there would be no escape. It was a battle between men, aided certainly by all the instruments and devices which science could provide, but still one that would be decided by the skill and endurance of men and by the intensity of the moral purpose which inspired them. Close quote. It was a battle between men, aided certainly by all the instruments and devices which science and engineering could provide, but still one that would be decided by the skill and endurance of men. And certainly, in my mind at least, what Captain Roscoe identified as the essential truth about the Battle of the Atlantic during the truly desperate days of 1940 to 1943 remains an essential truth today. It is not just about the ships and systems you provide, not about the instruments and devices that you deliver, but what our sailors can actually do with them, and do it under the most demanding conditions possible in a very complex battle space. And that already complex battle space grows more complex and more demanding every day. In a very prescient article in the spring 1995 Naval War College Review, Rear Admiral Yedida Yari of the Israeli Navy gave us a word of caution about the littoral arena, an arena we have moved into lock, stock, and barrel, with a fleet designed from the keel up for deep ocean, blue water operations. And we've done so with a strategic outlook that has been equally dominated by a classic blue water role of sea power. Admiral Yari pointed out how the traditional relationships of maneuverability and firepower are upset in the confined waters of the littoral. He discussed not just the growing intensity of the threat as we move closer to the shore, but the increased density of the threat, a density multiplied many times in recent years by the proliferation of precision and the development of defensive maritime options whose effects are greatly magnified in littoral waters: missiles, mines, special forces, guided rockets and projectiles. And in the littoral, these expanded threats can come at any time from any bearing. Ships must maintain a constant, all-dimensional state of alert. And you can imagine the degradation of crews, equipment, and readiness that can and does result from prolonged combat operations in that kind of complex environment. Precisely the environment we expect our sailors to operate in, fight in, and win in, perhaps in the Persian Gulf, or perhaps the South China Sea. Just to remind you, an SSN-22 in its coastal configuration, cruising between 720 and 740 meters per second, about 1,400 knots, assuming a launch range of between 20 to 30 miles, gives a ship about 25 seconds to detect, identify, decide, and engage. Throw in the many environmental impacts on radars operating close to shore, a multitude of white and gray shipping in the vicinity, a growing array of other tactical and theater SSMs and ASMs, and you have an operating environment of truly extraordinary complexity and violence that is growing more complex and more lethal every year. Growing complexity, number one. Today's environment, the littoral, expanding in threat intensity and threat density. Growing complexity, number two. Today's ships and combat systems. And not just combat systems, they're engineering control systems. And those that you are designing and building today for tomorrow's Navy. Please conduct a thought experiment with me. Think back to a wonderful day, July 4th, 1991, in the commissioning of USS Arleigh Burke, DDG 51, in Norfolk, Virginia, the first in her class. In the interest of time, I won't go through the entire litany of her as-built combat systems or the capabilities of the commissioning crew. And believe me, we stacked the deck on that commissioning crew. But it was the first DDG Aegis combat system and the basis for the evolution of that entire class. Now hold that image, and next to it, put the image of Arleigh Burke, and with her decidedly blue water focus, put the picture of the USS Gravely, DDG 107, just deployed last week, I believe, to to spend her entire operational period on deployment, probably within 20 to 25 nautical miles of land, perhaps in the Eastern Mediterranean, perhaps in the Persian Gulf. Above decks, inside the deck house, and in the engineering spaces, the closer you look, the more differences you'll find from DDG 51. And across the board, those differences add up to a far more complex ship, which will be operating in a far more complex environment with a very different and very difficult set of missions to accomplish. Now look at Gravely's crew. Fewer and less experienced than Arleigh Burke across the board in every rate and rating. Has their training ashore and the training that they can do afloat kept pace with the challenges that Admiral Yari described that certainly await them? Has it kept pace with the challenges, operational and maintenance, that their current combat systems presents them? Challenges to be met by a smaller, less experienced crew. Now take the next step in our thought experiment. Look at DDG 113 and what we expect to build into that ship. The Advanced Missile and Defense Radar, the Flight 3 Arleigh Burke, Integrated Air and Missile Defense, Aegis Baseline 9, CEC, Navy Integrated Fire Control, Counter-Air, the ability to fire SM-2, SM-3 Block 1B, and SM-6 missiles, true integrated air and missile defense capability. Now think, compare what we will have to do to prepare the crew to extract all that capability from that ship and what we are planning on doing with what we did for the commissioning crew of Arleigh Burke. Are we in fact ready for the investment in the crew that will be necessary, absolutely necessary, to realize any of the investment in treasure that we have made in that ship that we plan to sail? I maintain that the issue, matching the capability of the crew with the complexity of the ship to be able to prevail in the most complex battle space in the maritime domain, the littoral, deserves far more attention than it is getting now. A brief perusal of the discussion panels and the presentations given over the past few days show an overwhelming concern with the efficiency of ship construction and acquisition, and an absolutely underwhelming concern with the only end state that truly matters, the combat effectiveness of those ships and those crews that take them to sea. The most glaring example we have before us today is a significant mismatch that exists between the inherent complexity of the littoral combat ship, both variants, in the sea frame and the mission modules, the complexity of the battle space in which the LCS is expected to operate, and the overall operational capacity of the crew. And crew capacity is a measure of both numbers and experience. The complexity-capacity mismatches I've discussed today must be dealt with if you are to deliver the combat capability that is so urgently needed in the surface fleet today and into the future, a capability that comes at such high costs. I believe to the marrow of my bones that you are the ones who need to deal with this issue head-on if there is to be any hope of reversing the current technology runaway, dealing with the growing divergence between ship system complexity and crew capacity in the face of constantly growing complexity in the battle space. Now, we can't control that complexity in the littoral. It's where we have to be, but I believe we are more than capable of better aligning the capabilities of our ships with the capacities of our crews so they can prevail in the littoral. I'm not a Luddite, and I'm not advocating dumbing down our ships or giving up on fielding the capabilities that today's battle space demands. National missile defense is coming to the United States Navy, regardless of how sequestration ends, regardless of how the continuing resolution works out. 5 to 10 years from now, Ballistic missile defense in the Navy will grow to national missile defense, and that will be carried by the ships of the surface fleet. And the crews of the surface fleet must be ready for the complexity of that mission. I am advocating a far greater investment in human systems integration to close the growing gap between our crew's ability to operate and maintain the ships and combat systems you are delivering and developing, particularly in the DDG-51, the LPD-17, and LCS classes. Remember, it was a battle between men, aided certainly by all the instruments and devices science could provide, but still one that would be decided by the skill and endurance of men and by the intensity of the moral purpose which inspired them. Perhaps next year, there's room on the ASNE Day agenda for this issue, and I would urge you to consider that. Thank you for this opportunity to come out of the dugout and get on the field one more time. It was a great pleasure to be with you, and I'd like to offer my personal congratulations to the award winners today and from last night for your contributions to this Navy. Though my uniform is gone, my blood still runs blue and gold, and I think about every day. So thank you all very much.
Admiral, once again, you have challenged us to do more for our men and women. You know, I don't know Admiral Harvey personally or directly. I know what a stir he caused the last time he gave an address to our group, and I thought we had a great meeting this time, and I know you didn't intend it this way, but I feel a little bit pricked because we missed something, and it's our men and women. And I agree with you, we need to do more, and I'm sure next year at ASNE Day, you're going to hear more about this. We've done human systems integration conferences, but I think we can bring it to our national forum and continue to try to push that ball. Very complex question, and you were right on to call our attention to it and challenge us to go look at it. I'm going to, before I close this session today, I'm going to invite Joe Luckert up for 1 minute. And hear me, Joe, 1 minute to kind of give a plug for one of our next large symposia coming up.
I'm Joe Luckert, chairman of the Fleet Maintenance and Modernization Symposium 2013. It's the end of August, the 27th, 28th out in San Diego. And it's going to be a big opportunity, and we're working on the planning right now. We've been doing it for the last 3 months. And I know everyone's worried about travel, but I think we're planning as if there's nothing stopping us. We're going to have principal speakers working with CNO again, 3 panels with 06, flags, SES, and 30 presentations of papers. And also the idea that week will be the last week in August. It's the week before Labor Day. And San Diego is the place to be, particularly that weekend. There's a tall ships opportunity. There's the SeaWorld, the zoo, and a lot of other things. And I'm working on a day before with a CNO availability presentation like they did in fleet maintenance in Tidewater. I think that's a presentation that I think everyone who's involved in ship maintenance needs to listen to. I mean, I went for a purpose. I was the last director of para in San Francisco. With SurfMep coming up, the new acronyms, they've added some new steps. They've changed a Potnite to a Tissera. But I mean, all these things you need to understand if you're involved in ship maintenance. And I think it's well worth the time. So try planning with exhibits. In 2011, we sold out at the end of January for a meeting in August. We're working now. We have about a third of the exhibits sold, and we're working to do it as soon as possible. I mean, I've added 35 more booths. We ran out. We had 25 companies sitting and waiting. We lost money, they lost the opportunity to blow their horn. So take advantage of it and start signing up now. The papers, the abstracts are due by March 8th. We waited until after ASNE so that people got their mindset off of this and worked on the next one. Thank you for your time, and looking forward to seeing you in San Diego. Thank you.
Thank you, Joe. And the Fleet Maintenance Symposia have been absolutely superb. I was an acquisition person, and I didn't get to much of the fleet maintenance business over my career. I've had exposure to it as president of society, and I haven't been to one that wasn't superb. I want to thank everybody for coming to the awards ceremony today, and my sincere thanks to our presenters for joining us, and once again, congratulations to all the award winners. This is my final opportunity at ASNE Day to lead the activities at this impressive event, and I want to encourage you all to continue supporting your society with your time, your contributions, both technical and financial. ASNE exists to serve our nation's naval and maritime forces, as well as the membership of the society, so we can help ensure the nation's sea services remain the best in the world. Thank you all for coming. Have a very safe trip home, and I look forward to seeing you at our next event.